Welcome back to the deep dive. Today, we're looking at something pretty interesting in AI and healthcare.
Yes, it's quite a shift.
Right. How cutting edge AI is evolving and what happens when, the big tech players start giving away their really advanced stuff for free.
Mm,
That's what we're exploring today, focusing on Google's move with its MedGemma AI models. It's quite unprecedented.
it really is.
So, our goal here is to unpack why this decision to open source MedGemma is such a big deal. What can these models actually do? And what are the bigger implications for healthcare access around the world?
Absolutely.
Okay, let's unpack this. What makes Google deciding to open source MedGemma so, well, significant? It feels like a real departure from the usual playbook, monetizing AI with subscriptions.
It does seem counterintuitive at first glance, doesn't it?
Yeah, why give it away?
Well, there's a deeper strategy here, I think. It's about trust and control, especially in healthcare. Hospitals are, understandably, very careful about patient data. It absolutely cannot leave their premises.
Right, security is paramount.
Exactly. And research institutions, they need AI models they can rely on, ones that won't suddenly behave differently after an update they didn't control.
Ah, consistency. Okay.
Precisely. So by making MedGemma open source, freely available, Google lets these hospitals and researchers run it on their own servers.
So it stays in-house.
Yes, they can modify it for their specific needs, maybe tweak it for a particular type of imaging or patient population, and crucially, they trust its consistency. That's gold in medical applications.
So it's less about immediate cash and more about becoming foundational, like building the underlying infrastructure that everyone trusts and uses.
You could certainly see it that way. It's a long game.
Yeah.
Building trust, embedding their tech, even without direct subscription fees for this particular model.
Okay, that makes sense strategically. Now here's where it gets really interesting. Let's dive into the MedGemma family itself. What are these models?
Right. So MedGemma is Google's latest offering specifically for healthcare AI tasks. It's built on their Gemma architecture, which is already quite powerful. And these are described as their most capable open models designed for understanding medical text and images. They've released a few different configurations.
Different flavors for different needs.
Kind of. You've got MedGemma 4B. The B stands for billions of parameters, roughly indicating size and capability. This one's multimodal.
Meaning it handles both text and images, like reading a report and looking at the scan.
Exactly. Then there's a much larger one, MedGemma 27B. This comes in two versions, one just for text and another multimodal one like the 4B, but obviously more powerful for complex reasoning.
Okay, a bigger brain, so to speak.
Yes. And then there's a really specialized one called MedSick. It's smaller, 400 million parameters, but laser-focused on understanding medical images. Think of it as the visual specialist.
Got it. A whole toolkit. But how good are they? I mean, lots of models get released. What makes these stand out performance-wise?
Well, the numbers are pretty compelling. Take the MedGemma 27B text model. It scored 87.7% on MedQA.
MedQA, that's like a standardized medical board exam, right?
Essentially, yes. It's a benchmark testing medical knowledge. Scoring that high puts it right up there, competing directly with some very expensive closed proprietary models.
Wow. And it's free and open source.
Exactly. And importantly, it needs way less computing power to run compared to those giant proprietary systems. That's a huge factor for accessibility.
What about the smaller one, the 4B?
Even the MedGemma 4B model did respectably well, 64.4% on MedQA, which for its size category is actually quite strong.
Okay, so they perform well on tests, but tests aren't patients. Has there been any, real-world validation?
Yes, and that's crucial. Google highlighted a study where board-certified radiologists looked at chest X-ray reports generated by the AI.
Okay.
We found 81% of those AI-generated reports were accurate enough to potentially guide actual patient care decisions.
81%. That's significant. That feels like it could actually be useful in a clinical setting.
It's a strong indicator, definitely. It suggests the model isn't just pattern matching, but generating clinically relevant information.
So these theoretical capabilities, the good test scores, the promising validation, how are they actually being tested out there in, real hospitals, real clinics?
We're starting to see some interesting examples. What stands out to you as we look at these?
Well, I saw Deep Health in Massachusetts is testing MedSick Lip. That's the image specialist, right?
That's the one.
They're using it for chest X-ray analysis,
Yeah.
kind of like a second pair of eyes, a safety net.
Exactly. Helping to catch things that might be missed or providing a quick preliminary read.
And then there's this example from Taiwan at Chenggung Memorial Hospital. Researchers found MedGemma works well with traditional Chinese medical texts.
Yes, which is fascinating. It shows the model isn't just limited to Western medical terminology or data.
Mm.
It demonstrates real versatility across different languages and medical contexts.
That's huge for global application.
Yeah.
And then Tap Health in India, they specifically mentioned reliability.
Right. They made a point that MedGemma seems to show genuine understanding of the clinical context.
Unlike some general AI that can sometimes, what's the term, hallucinate, generate stuff that sounds plausible but is medically wrong.
Precisely. Tap Health felt MedGemma was less prone to that, sticking closer to medically sound information. That's incredibly important for trust.
So these examples point towards the practical potential. But how does the open source nature really truly boost accessibility and innovation globally? You mentioned lower compute needs.
Yeah, that's a massive part of it. These models are designed for efficiency. Some can run on just a single graphics card, not a huge server
A
farm.
single GPU, like what a serious gamer might have.
Potentially, yes, or what a moderately equipped lab or hospital department could afford. And the smaller versions, like the 4B, might even be adaptable for mobile devices eventually.
Wow, okay. So AI analysis potentially on a tablet in a remote clinic?
That's the vision this opens up. Point-of-care AI applications. Imagine doctors in regions without fancy hospitals or high-end computing infrastructure being able to get sophisticated diagnostic support right there.
That really lowers the barrier to entry.
Dramatically.
Yeah.
Smaller hospitals, researchers in developing countries, medical schools,
Mm.
they can now access this cutting-edge tech. They can experiment, build specialized tools for local needs, maybe adapting it for prevalent local diseases, for instance.
It feels like it could genuinely democratize access to advanced medical AI tools.
That's the hope, and I think that's a big part of the why behind Google's move.
Okay, this all sounds incredibly promising, almost revolutionary, but
Yeah.
there's always a but, right? Google themselves have stressed these models aren't ready to replace doctors.
Absolutely not, and that's a critical point we have to keep hammering home.
So what are the key limitations? Where does the human doctor remain essential?
Well, first, these are tools. Powerful tools, yes, but they need human oversight.
Mm-hmm.
Always. Clinical correlation, does the AI finding match the actual patient presentation, their history, other tests? That requires a human expert.
You need someone to connect the dots.
Exactly. And validation. Before any AI is deployed widely in a hospital, it needs rigorous local testing and validation on their patient population with their workflows.
Makes sense. And the AI can still make mistakes.
Oh, definitely. Especially with weird cases, unusual presentations, or scenarios that just weren't heavily represented in the training data. Edge cases are always a challenge for AI.
So it's not infallible.
Far from it.
Yeah.
And beyond just accuracy, think about the human element. An AI can process data incredibly fast, spot patterns we might miss, but it can't show empathy.
Right.
It can't sit down with a patient and their family, discuss difficult choices, understand their fears, factor in their life circumstances, their values. That holistic understanding, the judgment, the experience, the ethical responsibility that remains fundamentally human.
The AI provides information, the doctor provides care.
That's a good way to put it. The AI augments the doctor's capabilities. It doesn't and shouldn't replace the doctor-patient relationship or the core aspects of medical practice.
So pulling this all together, what does it all mean? We see healthcare systems everywhere facing huge pressures, staff shortages, more patients, the need for efficiency.
Yeah, the strain is undeniable in many places.
Could AI tools like MedGemma genuinely offer some relief? Not by replacing people, but maybe amplifying them, making expertise more available.
I think that's exactly the potential. Amplifying human expertise, handling some of the data processing burden, providing decision support, perhaps speeding up analysis, freeing up clinicians to focus on those uniquely human aspects of care we just talked about.
And making that amplified expertise accessible more widely, thanks to the open source, efficient nature of these models.
Precisely. This release really could be a pivotal moment. Lowering the barriers to entry for sophisticated medical AI is a big deal. It could accelerate innovation globally.
Especially for communities or institutions that maybe haven't had access to the latest, most expensive tech before.
Exactly. Think about researchers tackling diseases prevalent in specific regions, or smaller clinics getting tools previously only available at major centers.
So as we wrap up, here's something to think about for you listening. How might this kind of democratization of advanced medical AI really change healthcare innovation over, say, the next 10 years?
What new things become possible?
Yeah, especially for those communities and institutions that have maybe been on the sidelines of tech advancements. What specific local health challenges, maybe diagnostic bottlenecks or screening difficulties, could finally be tackled now that tools like this are becoming widely accessible?
It opens up a lot of questions about the future.
It really does. What localized solutions might emerge when the tools are in more hands? Something to definitely keep an eye on.